All right, welcome to the 9th episode of creating a Lisp with Swift and Claude Code. Today we're going to implement the let special form. But first, while we were gone, I fixed some things. I forgot air checking in our if implementation. So now if you do if and you don't give enough arguments, you'll get an error. I also changed evaluation of lists. It was currently left over that it would try to evaluate the first element of a list. So if I go 1, 2, 3, it'll try to evaluate 1. It's not a function. That's how it's supposed to work. Before it was evaluating 1 and just returning list, much like a vector, but now it's behaving correctly. So with that done, let's go implement our let function. So first of all, here's the prompt. Implement the let special form. If the first element of a list is the symbol let, then it should be followed by a vector containing optional pairs of symbols and init expressions, and then followed by 0 or more expressions. The result of the let should be the result of evaluating the last expression. If there are no expressions, return nil. The vector of bindings can be empty, but the vector itself is required. Before evaluating the expressions, create a new environment whose parent is the current environment, and add to this environment all the symbols in the vector initialized to their init expressions. The expressions after the vector should be evaluated in this new environment. So what that looks like in Clojure is something like this. So we can have like A is evaluated to 3, and B is 2, and in that environment we're going to add the 2, and we'll get 5. So that's what we're going to implement, and this is used a lot to introduce kind of like local variables, except these variables are not mutable. So anyway, all right, let's go. Let's try this. All right, this is a brand new session, so it's got to get reacclimated to everything and read all the code and everything. So I hope everyone's enjoying this. I'm enjoying this. I wish I could do it faster, but I have other things to do. And I don't want to overwhelm everyone. But, if you like this work, please like and subscribe the video. In the show notes, there's links below in where you can buy me a coffee if you want to support this work. I would really appreciate it. And hopefully we can get this to something that is actually useful. That's the plan. All right, he's about to write out the plan. All right, here's the plan. Swish needs a let special form for local bindings. A core Clojure feature let creates a new lexical scope. Yes. Evaluated body and returns the nil. Yes. That is what it looks like. All right. Challenge. The evaluator currently uses self environment implicitly for let to work correctly, including nested lets. Eval must know which environment is current. The fix is the thread and environmental parameter through eval. I assume that means passing an environment to val. That's what we really want. Refactor eval to accept an environment. That's true. Exactly. Keep the public entry point as a convenient wrapper. Okay. Update all recursive calls to pass the environment through. Update def to continue storing in self environment. Global, not that environment. That's correct, I believe. Add let validation to parser. Okay, in parse list, add validation requires elements to the vector has an even number. Okay, require, yep. Add let evaluation in eval after let. Okay, yeah. All this looks good. Creating a new environment with the parent, the current environment. Then he drops those first thing and evaluates all the bodies. That looks good. Init expressions are evaluated sequentially in let environment, so later. Okay, that's exactly how Clojure does it. That's exactly what we want. And then we have these test cases. Okay. I think that looks good, so let's do this. It's going to do the evaluator first. There's the changes. Now it updated the parser. Now we're going to add the tests. It's added evaluator tests and parser tests, and it's running the tests. And it is done. All right, let's go try this out. All the tests pass. I spoke too soon. Let me see. Back there. All right, let's go try this out. Let A be 1, B be 2. You notice how my REPL is much better than the closer REPL as far as indentation goes, which I like. And now we're going to add A and B, and we should get 3. And we do. Let's try some error checking. That should be nil. We should be able to do that. All right, looks good. Still defining. Let's check overwriting. So I'm going to define a global A, and then we can say, let's do our this expression. Now we should still get 3, even though the A there's 5. What happened? We did get 3. Okay, good. All right, that looks good to me. Let's go see what the code is doing. Let's check out the parser first. We've got a new error case. And we've got a new code to evaluate our let special form with error checking. Okay, there's some things I didn't test, so that's good. And that's it. Let's look at the eval. Eval, we now have two evals, and the main eval now takes an environment that's going to evaluate everything in. So we're propagating that environment in all the evaluations. And here's our new evaluation of let. More validations of the arguments. We create a new environment, we set up all the bindings, and then we evaluate the expressions in that new environment. All right, and we've got evaluator tests. And parser tests. All right, so that looks good. That's done. In our next session, we'll be doing the, we're going to finally do function literals. And eventually, I might want to do some refactoring because some of these files are getting really long. We might want to split them out into separate files. And some of these methods that it spits out are long too, so we might want to split them up into more functions. I tend to favor small functions. So I hope you like that. Stay tuned for the next session, and like I said before, like and subscribe and buy me a coffee. Thanks.